Hello everybody. I want to have a discussion about the plasma applications in the field of photonics. I have categorized the plasma technology applications in the field of photonics into the four categories. First of all, I want to speak about the traditional light sources. As you know, they are very much important and they are all based on the plasma technology. The second applications of plasma in the field of photonics is related to gaseous discharge lasers. The third category, which is very much important, is related to electromagnetic materials which are developed based on the plasma technology. And the final category is related to microcavity plasma lamps. In the following, I want to provide you some examples of applications of plasma technology in the field of plasma photonics. First of all, I want to provide you an example of about manufacturing of electronic devices in micro and nano scales. For example, plasma etching for semiconductors or PECVD, plasma enhanced chemical vapor deposition for deposition of the thin films, and also surface modification and cleaning of wafers using reactive plasma are very much important in the field of manufacturing of different devices in the field of photonics. Another example is related to disinfection devices, which are, as you know, there are many air purifiers in the hospitals and public space which are based on the plasma technology, and also cold plasma technology devices which are used for the sterilization of surgical tools. And another important applications of plasma in the field of photonics is related to producing plasma for example, to produce UV lights for water purification. Another two examples are related to atomic clocks and different gaseous lasers. I have already talked to you about the gaseous lasers, but atomic clocks, in the atomic clocks, we have to talk about some important issues. In these atomic clocks, plasma ion sources for and high precision atomic beams generated. And cesium and rubidium plasma lamps are used in atomic clock excitations, and also we can talk about the plasma based frequency standards in timing and navigation systems. As I have talked to you, um, plasma has interesting applications in development of many different gaseous lasers. For example, carbon dioxide lasers for industrial cutting and welding, for helium and helium neon lasers, which are very much applicable in the alignment and metrology. And as you know, excimer lasers for eye surgery and different medical applications and semiconductor in lithography. These are the applications of plasma technology in the field of gaseous lasers. Another example related to laser plasma interactions. In fact, it is related to generation of attosecond pulses for the ultra fast spectroscopy, and also laser wave field acceleration (LWFA) for the compact particle accelerators, and also generation of high harmonics for table type EUV and XUV and soft X-ray sources. Another important applications of plasma in the field of photonics is related to X-ray sources. In fact, the plasma-based X-ray sources for non-destructive testing is an important applications of plasma in the field of photonics. Development of compact synchrotron alternative, which are based on laser-driven plasma, and also it has many applications in medical imaging and cancer therapy, and which is performed via laser accelerated particle beams. And finally, the final example is related to laser fusion energy. I want to speak about inertial confinement fusion (ICF) at the facilities like NIF and LMG, and also laser driven pellets compression for clean energy production. And I want to tell you that there are many research are going on the ignition thresholds for fusion energy scalability and many other applications. Thank you for your attention.